Alright, so here is the video for Chapter 5 summary. So as you can see, this is going to be a little bit lesser quality in the videos that you've seen before, mostly because I'm just trying to get this all done quickly and posted so that you can have it before the break, so you can focus on this whenever you want, and also if you want to start already on the Chapter 4 and 5 project, you can do that as well. So let's get into this. In this summary, the purposes are going to be, first, I want to show you the material that you will probably see in the future. So if you're going to continue on in math or science or engineering or stuff like that, you're most likely going to see stuff from this chapter, so I didn't think I could just eliminate it entirely. I wanted to at least show you some of the stuff so you've seen it before, and I'm going to quiz you on some of this as well. So one of the things we're going to do is I'm going to show you the shape of sinusoidal graphs. Sinusoidal just means one of the trig ratios. So sinusoidal means it repeats and it's cyclical. And we're going to figure out what are the characteristics of this graph. Let's look at sine x. So if y equals sine x, one of the things you can do is you can first make a table of values. And this is just looking at the different points. What is going to be my y value given that x is a given angle? So if the angle is 0, my y value is 0. If my angle is pi over 2, then sine pi over 2 is going to be 1, and so forth. And what this graph is going to look like is this nice little wave pattern going on. And so this continues on both to the right and to the left. And you'll notice there the amplitude. So amplitude is just from that middle line, the x-axis, up to the highest point or to the lowest point. That is always going to be 1 because the radius of my unit circle is 1. And this is just the definition of how that works. The period is 2 pi, meaning it does one complete rotation or one complete cycle in 2 pi angle, or an angle of 2 pi, or 360 degrees. So this graph correlates to, at an angle, what is the y value on my unit circle. And here's just a bunch of properties of this. So the domain is x is all real numbers. The range is from -1 to +1. You've got a maximum value at 1. You've got a minimum value at -1. I already said the period, the amplitude. My y-intercept is 0. So where it touches the y-axis is 0. And my x-intercept is cyclical. So every pi, 0 pi, 1 pi, 2 pi, 3 pi, and so on and so forth, that is an x-intercept. So these are some properties of sine x. Cos x is going to look very similar. So again, we can make a table of values, and from this we can draw a graph. Notice here, when we're plugging in x equals the whatever angle it is, the y value here actually represents what is the x value on my unit circle. Now that's going to be a little bit confusing when we're graphing in between these, but if we look at this, so here's our graph. Notice this, it might not seem like it looks the exact same as a sine graph. It is, you're just starting at a different position. And that's because when my angle is 0, my x value is +1. As opposed to sine, it starts at 0. So my amplitude is going to be the same, the period is going to be the same. We're just starting at a different position. Again, when you're plotting this, looking at the graph there, my x value is the angle. The y value is going to be the x value on my unit circle. So this makes sense. At pi over 2, my x value is 0 if you look at the unit circle. Again, properties of this, domain, range, max, min, period, amplitude are all the same. The thing that changes now is the y-intercept is at +1 instead of 0. And the x-intercept, you can see it on the graph there, is at pi over 2, and then plus pi times an integer, meaning it can be positive or negative. Here's a useful hint. So like I said, Sine and cosine are very similar, and it can be confusing to remember where does each of these start. But you can think of it like this. Sine starts in the middle. Notice sine, the middle letter is I, which can also form middle. If I'm dealing with cos, I start at the top. So you can just remember with the middle letters, sine has an I in the middle, so it's for mid. Cos has an O in the middle, so it's top. Just a useful hint to remember which one's which. Now, tan x, before I show it to you, don't freak out. I'm not going to actually give you this on the quiz. I wanted to show you what it looks like so that if you see it later on, you will not freak out. It looks like this. Remember, tan x is just sine x over cos x, and this is what you would get. So just so that you're aware, if you see a graph like this, it's just relating to a tangent function. And there's the properties. I will leave it there for a sec. I'm not going to go over all of these specifically, but this is just what a tangent function looks like. Again, it's not on the quiz. It's not coming on the test. I just wanted you to see it so that you don't, so that you recognize it when you see it later on. Now we're going to get into all the characteristics of these graphs. And each of the characteristics actually is related to transformations. So as we go through this, you will be able to see each of the characteristics relates to not only a something that's relating to the graph, but it also will talk about the transformations. So if we look at that amplitude, I showed you the amplitude already. It's just between the midline and the highest point or the lowest point on your graph. And this relates to vertical expansion or compression. So this is our A value. Conveniently, amplitude is A. And this is the A value that you've seen before in Chapter 1, Chapter 7, Chapter 8. All of those ones you've seen this before. Let's try this as an example. So graph y equals 2 sine x and y equals negative a half sine x. So 2 sine x, this is the blue line here where my amplitude doubled. I expanded it vertically by a factor of 2. The green line is the other graph. Y equals negative a half sine x. Here my amplitude is a half, and I've done a vertical reflection. So instead of my sine graph initially going upwards, now it's initially going downwards. So that's my amplitude. The period relates to horizontal expansion or compression. So the period, again, is how long does it take to do one complete rotation on your graph? And this relates to the B value. If we wanted to graph cos 1 over 3x and cos 2x, notice here we have the same kind of thing with expansion and compression. If B is 1 over 3, that means I've got a horizontal expansion by 3. If B is 2, I've got a compression by 1 over 2. Exact same thing as what you've seen before. We can graph that. Notice, if I'm compressed, that's the green line there. It gets smaller. And with cos 1 over 3x, we're expanding. So with these B values, we can actually conveniently calculate what the period is. The period is equal to 2 pi over B or 360 degrees over B. Depending on what units you're dealing with, you can write it out as such. But I can conveniently calculate what the period is for each of these graphs. For the blue line, it's 2 pi over 1 over 3, so 6 pi, as you can see on the graph there. And the green line, the period is 2 pi over 2, because the B value is 2, and so therefore the period is pi. Meaning, I need to get from the top, because it's cosine, down and then back up to the top at those exact periods. Next is displacement, and displacement talks about vertical translations. So on a sinusoidal graph or trig graph, displacement means what is the vertical translation? And this relates to the k value. Suppose we have y equals sine x plus 3. This is a vertical translation up 3, or a displacement of 3, depending on how you want to say that. But this is what it means. Here is our sine graph, and it's just simply shifted up 3. So instead of the midline being at the x-intercept, we have it's now at positive 3. The period's the same, that rotation's the same, and my max and min have changed. My maximum went from 1 up to 4, and the minimum went from -1 up to 2. And there's these specific equations to calculate that. So this is convenient if you want to be able to specifically figure out what those values are. And also notice the range has changed as well. So as I translate 3 up, my range went from -1 up to 2 and +1 up to 4. Phase shift, last characteristic, and this is the horizontal translation. You might see this in the textbook written as C, and the last slide you might see it as D. I changed it here in the notes to be more familiar with what you've seen before, but you might see those as C and D, just so that you're aware. If I've got something like this, y equals cos x minus 60, so that means I've got a horizontal translation or a phase shift of 60 degrees to the right. So it's still the opposite like we've seen before. So as we look at our graph, remember cos of x start at the top, and now what's happened is that top part has shifted over 60 degrees. And each of the other points has also shifted to the right 60 degrees. So that's a phase shift. It just means you're translating to the right or to the left. Let's do an example here. So we want to determine what the equation of the graph below is. So in this graph, we want to figure out what are the a, b, h, and k values. So going from graph to equation, first we're going to assume, because looking at this, we're starting from the midpoint and then we're going down. So we must have a vertical reflection. That's what VR there is. So a sine graph with a vertical reflection. You could, if you wanted to, you can also say it's a cosine that's shifted 2 pi to the right. We could say it's a sine graph that shifted 4 pi over 3 to the right. There are basically an infinite number of solutions that you could get for this. So that part is a little bit up in the air. You can, whatever you recognize first, sine or cosine, it doesn't matter. You just need to find some starting point and then work your other values from there. With this, my maximum is at 1. And my minimum is at -7. From this, we can get what the a value is. Well, first k value, and then we'll get to that. So k is the maximum plus the minimum over 2. This is just a generic equation, how you can get that. It's at -3. This can also be where the midline is. So if you wanted to try and find where the midline of this equation is, or the graph, you could figure it out from there. But this is an easy equation, because it's sometimes easier to find the maximum and the minimum. Then to get the a value, we want what's the difference from the midline to the peak or midline to the trough down at the bottom, which is simply just taking the maximum minus the minimum divided by 2. And that tells you how much your amplitude is. H is going to be 0. Since we assumed we're doing a sine graph with a vertical reflection, that means we're starting at the initial point. We haven't shifted left or right. And then we recognize the period is 8 pi over 3. So to get the b value, we just do 2 pi divided by the period, which gives us 3 over 4. So putting all that together, we get this equation. So that is the end of this. I didn't do a lot of examples for this. The main things you can expect coming on the quizzes, I will tell you in class. But make sure you're checking out the practice problems that are posted up on Google Classroom, and you'll be able to see from there what kind of questions you will be getting on your quiz. But I'll be able to answer more of these questions specifically once we get back into class. So that is a very quick summary of Chapter 5, and I will see you after the holidays. Alright, so I got the most amazing, bestest ever after video thing for this last video. It is the end, and so I thought I would put in something that's very special, at least for some of you. Some of you might not even care, you might think this is the worst ever, but that's okay. What I'm going to do for this video is I'm simply going to read out the prologue to my novel. Now, as a warning, this is a work in progress. It is a rough draft. I did a very quick edit as I went through, but it is not finalized. If you want to give some feedback, that'd be great. I can take that into consideration. I won't necessarily change it because I'm not going to change every bit of feedback that I get, but I might change a few things. That being said, it's not its final point, and it might not be the greatest at this point as far as the sentence structure and stuff like that, but I'm excited. I think it's still pretty good. So that's what I'm going to do, is I'm going to read that out for you. If you're not interested, just don't watch it, and that's totally fine. I won't be offended by that. Alright, I'm going to start this off by saying this is really weird to read out my novel and what I wrote. I don't know why it feels weird. I can't imagine authors who record their own audiobooks. I mean, you can do the right character voices and pronounce it how you want, but it still feels weird. Okay, here we go. Prologue. Naaman flew backwards, slamming into the concrete wall, his head spinning. Not only from hitting into the wall, which would have been reason enough. Their plan was failing. For years, Naaman had been setting a plan into motion. It started as a self-obsession. He was later joined by his wife, Jessa. She had the same passion, if not more. They schemed. It was a matter of life and death. They needed a way to kill the man who was taking over their world. Over time, they recruited more to their cause. People fed up with how things were. People wanting what life was like centuries ago, before he came. Their plan was simple yet efficient. They would take him by surprise. They would strike fast. They would kill him before he realized what was going on. Yet he did realize, and dismantled their plan in an instant. How could he have countered their plan so quickly? How could he know their weaknesses? There couldn't be a spy in their midst. Naaman and Jessa had picked their group very carefully. Only people who had lost as much as they did could join. People who had as much hatred for him as they did. No one would have given away their secrets. No one was captured and tortured. How did he know? And then there was his daughter, Faye. He had often wondered if it was right to have a child in the midst of planning a crazy mission that could end their lives. Faye was 12 now. She knew about everything they had planned. She was sweet and innocent. Now she would live without her parents, destined to walk the streets of Tizumo alone. Yet she was tough and strong-willed. She would survive. They had taught her well. Naaman gathered his strength and stood up. He glanced at Jessa's body beside him, her lifeless eyes staring into his, as if to say, "It's up to you now." He pushed forward. He had to win. Naaman shook his head to clear his vision. Someone screamed as they flew into the wall beside him and crumpled to the ground. It was up to Naaman. He picked up his energy blaster and fired at him, Tirek, the one who took over his world centuries ago, the one who they had been planning to kill, the one who killed his wife, the one who ruined his life, the one who would probably end his life. Tirek raised his blast shield to effortlessly block the energy bolts as he shot another of Naaman's allies. Naaman pulled weakly at Tirek's shield, causing Tirek to wobble a bit, but he quickly countered with his own pull. Naaman followed with a strong push that should have sent Tirek flying, yet he did not budge. Gravity boots, Naaman thought. He must be wearing gravity boots. There's no way an ordinary man could resist such a push. Naaman dashed behind a broken wall to think of his options. Pushing and pulling had no effect while Tirek's gravity boots were activated. He could try to catch Tirek mid-stride, but now that Tirek knew he was fighting someone with telekinesis, he would be weary to deactivate his boots. He could pull on some rocks and blindside him, or he could just charge and see what happens. "Are you going to sit there and think all day, or are you going to fight me?" Tirek called above the pinging of blaster fire. "I haven't got all day." Who's going to take care of Faye when her mother and father are dead, Naaman thought. She will have to fend for herself. She will have to use all that we have taught her. I hope she will forgive us for abandoning her. There was no other way. Naaman stood up and pulled out his energy sword. He ran at Tyrk, who was waiting, Naaman yelling as loud as he could. The bodies of all his comrades lay around him. He was the last hope for this world, the last man to stand up against Tyrk. He had to win. There was no other option. Tyrk smiled. I admire a man with guts to face me. Naaman swung his sword, aiming for Tyrk's head. Tyrk sidestepped and tapped Naaman on the shoulder with his blaster. Naaman swung again at waist height. Tyrk simply used his shield to block the blow. Tyrk chuckled. Do you know how many have tried to defeat me over the centuries? Naaman stabbed for Tyrk's heart, but Tyrk deflected the sword with his forearm armor. Naaman pulled at Tyrk's shield at the same time, but he could see it was firmly strapped to Tyrk's arm. Thousands upon thousands. None have succeeded. Your attempt was not even the closest, although I was not expecting a foes to show up on this planet. That is new. Naaman stood panting. The sword was heavy in his hands. He wiped the sweat to keep it from dripping from his eyes and blurring his vision. I am a gift to your world. I have saved it. You should be thankful. I do not deserve this reception. Once you realize the good I have done, you will all thank me on bended knee. Unfortunate that you will not see that day. Naaman felt his sword ripped from his hands by a powerful force, and then he flew into Tyrk's outstretched hand. Tyrk's fingers closed around his neck. He strained against Tyrk's grip, but it was no use. He was going to die. We failed you, Faye. Please forgive your mother and I. Alright, so that is the prologue. Like I said, feel free to give me feedback, what you liked, what you didn't like, what your thoughts are. And yeah, I hope maybe that'll get some of you excited. Hopefully that didn't deter anyone from reading my book, but that's the prologue for it.